Welcome to Brain Vision.
In this problem, you are asked to solve for the distance of the image for an object placed at 200 centimeters, at 40 centimeters, and at 10 centimeters. So your ray diagrams start off by labeling your focal, which is again 10 centimeters, 20 centimeters, from your mirror, and my center of curvature, which is twice that, is a distance, in this case, of 40 centimeters. And then my first object is placed way out here. This is not to scale. My first diagram is going to be, my first ray is going to be parallel to the principal axis. And then when it hits your mirror, it's going to reflect and go through your focal. And my second ray diagram is going to go through the center of curvature. Now, where the 2 points intersect is where your image is going to be located. So my image here, you can see how it's inverted, which means this is a real image. And we can prove that mathematically by using the mirror equation. So 1 over dO plus 1 over di equals 1 over f. And then I want to solve for di, so that gives me 1 over f minus 1 over dO. And then this is the part that students tend to forget. You do need to make sure that you get the inverse of this, so this is di equals 1 over what you get when you plug in your numbers on this side. So for part A, you can do 1 over 20 minus 1 over 200. So 1 over 20 minus 1 over 200, and then 1 over that gets you a distance of your image of 22.2 centimeters for part A. You can repeat the process for part B. So this is 1 over 20 minus 1 over 40. So 1 over 20 minus 1 over 40, 1 over that gets you a distance of your image of 40 centimeters. And the fact that it's a positive number here, both of these are positive numbers, both of these will be real, and both will be inverted. So then for part C, this one is less than my focal. My focal again was 20 centimeters. Because it's less than my focal, I can already tell this is going to be a virtual image. So if I draw my virtual image here, or I'm sorry, if I draw my object here, I still draw my ray diagram. So I'm still going to draw it parallel to the principal, and then it's going to go through F. And then my second ray diagram is going to go through C. And then it's going to reflect back on itself. Now you can see that they are diverging on this side, but they're converging if you were to backtrace these. And so all the way back here is where my image is being created. You can see how it's upright. So this will be a virtual image. And then we can prove that mathematically. So di equals 1 over f minus 1 over dO, which is 1 over 20 minus 1 over 10. And 1 over 20 minus 1 over 10 gets you a negative 0.05, but then you get the inverse of that, and you get a negative 20 centimeters here. Again, that negative tells me that this is in fact a virtual upright image.